we developed the same algorithm in the university. Bridgeport will be everywhere. So Bridgeport will not be important, so you can remove the Bridgeport by considering the Bridgeport as a suburb. Okay, so that is the first thing. After that, this is how we can use such a frequency. Okay, that means I don't know why this one is here. This is a recommendation system. As an example of your after data mining, you will see the example of the recommendation system, which means think about the Netflix. In the Netflix, one of the main tasks of the Netflix is they need to provide the latest information about the movie. Then you try to watch the movie. But that recommended movie should be relevant or that can attract the user, right? How can we find? The one way, there are different ways, but the one way is if his pattern is based on the history. So he watched almost the same as him. Okay? Then he select the new movie. Then he may like that movie. Okay? That is the idea. That makes sense. So if his watching movie pattern is the same similar as him, then if he purchase, then he may purchase. So that is the idea of this one. But we can consider the TF-IDF for this one. So we can consider his watching the movie list as a document, and then we try to find. So it's like that. Then anyway, so TF-IDF, this is a formal definition. TF means is term frequency, just the number of count for the keyword. And inverse document frequency is the kind of weight. Okay, so see, it's a total number of documents that n. So for example, I try to find search for this. Okay? From the UB database, UB web document. So we have HTML1, HTML2, HTML3, like that. Okay? And so how many times? It's 3 times of Bridgeport. Okay? How many times of Bridgeport? 2 times. And how many times of 1? And Lee is how many times? Just 1. Okay? Then 0, 0. This one happened 3, this one happened 2, this one happened total 2. So this one, if we just consider the frequency of the word, this is the most frequent document. Right? However, if we consider importance of the keyword, for example, the Bridgeport is everywhere. Okay, if we count but any document in the web, this server has the Bridgeport. What about the Lee? Even though that happened just 1 time of the document, but that's very important, critical word to search. That's the idea. So how can we make the mathematical model to measure such a way? N is the total number of documents. In this case, 3. For example. Then, number of documents that contain the term 1/3. So this is the least important. It's a 3. What about the Bridgeport? It's a 1. 3 over 3. Which one is important? This one is important. So we will consider lead. So this document will be written rather than this one, even though it happened 3 times. Okay? So that is the idea. So instead of just this one, we use the logarithm. Okay? So in case of logarithm, the 1 means log is a 0, nothing. Then it's going to be log 3. Okay? So that is the TF IDF is a times. It's a kind of weight. So not just the frequency times the weight. Okay? This is the TF, the IDF. So in the document processing, it used a lot. Okay? So we are going to use this one. We are going to use the MapReduce to implement this. There are 3 jobs. First program is the frequency for all documents. Okay? By word, document, and how often the report is. How often the report. So frequency. Then next one is weight. Compute the weight. This one. Which one? Each document has this keyword. This keyword. It's an inverse. That is the reason it's called the inverse document frequency. This one, first one is for each word, how many times occurred in the document. And the second one is the per document, how many the number of documents for the word. Okay, so number of documents. So that is the reason it's called the inverse. Then finally the third program, MapReduce program, compute the TF idea. Okay, so that's the overall the MapReduce setting. Okay, for each job, for each programming. So when you design, when you implement your MapReduce programming in your project, it's not just one MapReduce. Sometimes it can be the set of MapReduce programming. Also, sometimes you need to, from one MapReduce program, depending on the output of MapReduce programming 1, you can execute MR2 or MR3, then MR4 out. This is called workflow. So you need to consider workflow in your job. So you implement 1, 2, 3, 4 different the MapReduce programming, not sequential, but such a condition. This is called workflow. Workflow also managed by the Hadoop ecosystem, which is called the Woozy. Okay, we will see very briefly about the Woozy later. Okay, so you can use the Woozy. Word co-occurrence. Not only just one, so we will consider the how many times Bridgeport plus lead happen in the document. It will be many combination, right? So think about how many words in one page. Let's say 100 different. How many different combination? 100 combination 2, right? And if you consider 3, so 100 combination 2 plus 100 combination 3, so there are huge number. So definitely we need to use some MapReduce programming. Okay, it can be used for the shopping recommendation system. Why? If somebody purchased the, for example, tractor, okay, tractor, they are interested in the fertilizer, like the lawn care. Okay, so they are related each other. They will happen together in the transaction, per transaction. So when you purchase the milk, okay, from the Walmart, you probably purchase the egg also, milk and egg to make the scrambled egg. So you need to both the milk. So it's a co-occurrence. So you can use a shopping recommendation. Credit risk analysis. For example, if right now I'm not doing a lot, but when I was student, I did the balance transfer for 3 different cards to pay the first card and transfer from the second, something like that. So if we can see such a transfer and the payment by transfer and the transfer from others happen together within the 1 month or 2 months, then they may cause the problem, so risky. So we can use such a credit check, credit analysis for the word co-occurrence. Also, people of interest, okay, to find. So by extract the feature of the people, okay. So feature means the age or the profile information, demographic information. If co-occurrence happen, if you can find such a thing, you can use. Okay. So, but as you can expect, for each word, okay, in the document, and for each another word from the word. So how much in here? If that is close within given the condition, then will be here. This is a key and value. So many different cases. So we can get the benefit of the MapReduce programming to this one. The reducer is simple. We can just sum up the by pair. Okay. The last one is the and not last one. We have the joint. What is the time? 24. Let me 5 minutes. Okay. So secondary sort is this is the output of the reducer. So I'd like to, this is a key, this is a value. So I'd like to sort by the value also. So we can perform the MapReduce programming for that data. Okay, that is a secondary sort. Okay. It will take a time. Okay. This is a summary of the such a MapReduce common MapReduce algorithm. Okay. I think probably your project will be use one of these. Also, in addition to that, sometimes we need to use the join operator, which is not recommended. Okay, because our goal of the MapReduce programming is performance, how much fast to process. That is the reason even HDFS does not allow the writing the data or random accessing. However, if we allow the join operation, join requires huge research. Okay, read and write, and also the temporary space. But sometimes we need. So how can we do that? There are 2 types of the join. One is a mapper. Mapper can join the data. Mapper is more straightforward. So whenever that is called the lookup table or other table data. Okay, then mapper side join when you extract, when you create the pair of the key and value, so you need to check the specific value of the for whether certain value. So value is 1. 1 is Monday. Okay, so you can replace. Okay, you can replace such a data. That is the mapper side join. So mapper side join is straightforward. The problem, you need to join all the record. So if we can apply such a join for the reducer is much smaller. Okay, so but it's more complicated. Okay. So the idea is after we got this one, so we apply. But in the join, the output of the for the output of the reducer, the key of the reducer is already shuffled and sorted. So we try to use the benefit of this one to find the same key. So idea is, so this is the output of the reducer. This is a lookup table. So let's say this is employee and location. So we will, if that one is matched, okay. So in this case, a location ID, if we match, we find this is our the expected output. For the 3, the Levi Strauss is a 2, 2 is a San Francisco. Like that. It's a join, typical join. But to implement this one, so we combine all the possibilities, like this one. Like in terms of the relational model, it's a Cartesian problem. Then check only the condition that satisfy with them. Okay? So all combination, then after short-range sort, we take this one, this one. Because it's a null data, so we don't need. So that is the idea of reducer side of the join operation. Okay? So this one is an OR combination, but we will take the only that has the value in the key and value that has this one. Okay? So you can use. However, this is much more complicated to join. So it also takes a longer time than you expect. So nowadays, we can use a high or peak that we are going to learn later as a part of the Hadoop ecosystem. It provides interface. So it looks like the SQL code. Select from 2 tables where join condition. Then that code will be converted to this MapReduce program automatically. Okay? It's not really the relational database, it's a MapReduce programming, but it provides the nice, the simple, the SQL style, the interface. That is high. Pig is the script language style, the interface. So it's the same thing, converted. It will be converted to the MapReduce programming. And Impala is the Cloudera software. It's a Hadoop ecosystem. So not sure whether I'm thinking either Impala or Spark. I heard that Spark is more interesting nowadays in the market. So I'm thinking to introduce instead of the Impala, introduce the Spark at the end of the semester, depending on the available time. Okay? So you can use this one. So in your project later, I will introduce more details. You need to implement 4 applications. 2 of them are because you will form a team by 2. Okay, so each one will implement the 1 MapReduce program and 1 the non-MapReduce program, which means using Hive or Pig or any other Hadoop ecosystem. You understand what I'm saying? So one is the purely Java MapReduce programming, another one is non-MapReduce programming using Hadoop ecosystem. Then, because you have the team by 2, so total 4 applications. So you are going to submit the 4 applications for the same data set. Okay? So before that, you need to think about in your proposal. You need to think about what is the what we are going to implement. Then think about what types of the MapReduce programming and what application, what Hadoop ecosystem we are going to use. Okay. Hopefully, I'd like to cover the scoop from Hive and Pig before you start the implementation. But during the your proposal, we may not cover, but you can still look up in advance what we can use. Okay, and in your proposal, you need to propose 4 applications. The 2 MapReduce programming, Java MapReduce programming, and 2 the MapReduce programming based on using the Hive, Pig, and any the Hadoop ecosystem. Okay, any question? Okay, so after a short break, we will have the
Like this.
yes.